About 5 billion years ago, a star much larger than our own went supernova. In its death, it scattered its enriched guts across the universe, creating a cloud of dust and gas light years across. And in certain areas, this cloud of dust and gas clumped together and underwent nuclear fusion, forming the next generation of stars, such as our own. We are formed from the ashes of stars much bigger than our own. We are made of stardust. I'm Damon Scotting, and this is Astronomical.
$13.7 billion years ago, there was nothing. And then, the Big Bang. The Big Bang wasn't an explosion as per se. It was the expansion of time and space itself. In the beginning, it was infinitely dense and hot, but it expanded at the speed of light and cooled rapidly. Once temperatures were lower, the first particles burst into existence. They coalesced to form the first atom, hydrogen. For the first 200 million years, the universe was dark, until the very first star was born. This was the start of the stelliferous era, the age of starlight. Stars can come in many different sizes and colours. Depending on their mass, they typically take one of 3 different paths through life.
Now, low mass stars that have less than half the mass of our own sun are amongst the most common stars in the universe. These are the dwarfs. They can live up to trillions of years and spend most of their time in a stable condition, giving off small amounts of heat and light. When the universe dies, these will be the last stars to go.
A red dwarf is the smallest and coolest type of star in the main sequence phase. They're the most common type of star in the universe. Roughly 75% of the stars in our galaxy are red dwarfs. Just because they are small and give off little heat doesn't mean they don't have orbiting planets that are capable of supporting life. This is Proxima Centauri. It's a red dwarf and our nearest star. We recently discovered an exoplanet that orbits the star in just 11.2 days, 32 times quicker than the Earth orbits the Sun. The long lifespan of red dwarfs may make them ideal places for life to exist on. We've already discovered a number of exoplanets in orbit around red dwarfs. But being so close to the star leaves you overly exposed to any solar flares, which are very dangerous to life.
Now this is our own sun. It belongs to the next category of stars. Stars that have a mass between 0.5 to 8 solar masses. They will spend most of their life in the main sequence phase, before after 10 billion years they reach the end of it and swell into what's known as a red giant, burning off the last of the fuel remaining in their cores. And when it's all gone, gravity wins over and the star collapses inwards on itself, forming a supernova. This is a planetary nebula. The star has ejected its mass all across the universe, creating a cloud of dust and gas. And all that remains at the core is a white dwarf.
Our sun's lifespan is roughly 10 billion years. As it reaches the end, it will swell to as much as 250 times its size now, before it undergoes the biggest explosion in the universe, a supernova. Supernovas regularly outshine their host galaxy. This is a photo I took of M82, the Cigar Galaxy, before a star within went supernova. A single star in a galaxy containing hundreds of billions of others is able to outshine everything for up to a few days before things start to settle. They produced a shell of ejected matter known as a planetary nebula. These are relatively short-lived, lasting just 10,000 years. What remains at the core is a star now the size of the Earth, but with a mass similar to the Sun. This is a white dwarf. It's very hot and very dense, but they will live for trillions of years, slowly cooling into a black dwarf.
Now this is a super giant. With more than 8 solar masses, these are the biggest stars in the universe. And they all abide by one simple law. Live fast, die young. So after a few million years, when all their fuel is spent, these stars will go into a supernova. The large ones will collapse in on themselves and form a neutron star, amongst the densest objects in the universe. But then the really large ones, the biggest stars the universe has to offer, will do something even stranger. Now these stars are so massive that they can't stop the gravitational collapse, meaning they form a void in space. These are black holes, amongst the strangest objects the universe has to offer.
Black holes are still today one of science's biggest curiosities. There must be millions of black holes in our galaxy alone that are invisible to the naked eye. For stars that don't quite collapse in on themselves and form a black hole, they produce a huge nebula, a cloud of dust and gas. In certain areas they clump together, condense and form stars. Stars such as our very own Sun. During the early stages of the solar system's formation, things were chaotic. It wasn't until after the first hundreds of millions of years that the debris slowly coalesced to form the 8 planets we know today, some of which are far larger than Earth.
So what is the biggest planet in our solar system? And which one's the smallest? Well, the smallest planet just so happens to also be the closest planet to the Sun, Mercury.
Being the closest planet to the Sun, Mercury feels the full force of its heat. But due to its scarcely thin atmosphere, its nights are well below freezing. It's the smallest of all planets, even smaller than each of the largest moons orbiting Jupiter and Saturn. Mercury completes an orbit around the Sun quicker than any other planet. It takes just 88 days to do so. It's because of this that Mercury is one of the hardest planets for us to see. Due to its tight orbit, it never strays too far from the Sun's glare. Several times a century, you can see Mercury appear to pass across the face of the Sun as it moves in front of our view here on Earth.
Then we have the red planet, Mars, which is about half our diameter.
It is similar in many ways to our own planet, but Mars is a cold, dry world. Home to the biggest volcano in the solar system and one of its deepest canyons. Mars is a place of diversity that has been long suspected to have once harboured life of some form. The dried riverbeds on its surface, along with its polar ice caps and similar seasons to Earth, give us strong evidence that it hasn't always been a desolate wasteland. Mars has 2 moons, Phobos and Deimos. Each are only several kilometres in diameter, and they are believed to be asteroids that were captured by a young Mars's gravity. A day on Mars is just a bit more than 24 hours, whilst its year is 687 Earth days, making it almost twice as long as here on Earth.
Followed by Venus. Venus is Earth's hot sister. It's only about 200 kilometres less in size.
Venus is similar in many ways to the Earth. They are roughly the same size and about the same distance from the Sun. But one thing they don't have in common is that whilst the surface of planet Earth is a lush paradise for life, Venus is a type of hell. Its atmosphere is almost entirely carbon dioxide, and the thick layers of clouds prevent anyone from seeing in or out. On December 15th, 1970, the Russians became the first to land a spacecraft on another planet. It gathered data for 50 minutes before succumbing to Venus's intense temperature and crushing surface pressure. In the early stages of the solar system, Venus may have looked similar to the Earth. However, as the Sun continued to grow, it boiled away the water on its surface and added water vapour to the atmosphere, which led to a runaway greenhouse effect, trapping the heat on Venus. Now the temperatures regularly exceed 400 degrees Celsius. Venus is unique as it's the only planet in the solar system that rotates clockwise. A day on Venus lasts longer than its entire year.
Then we have our planet, planet Earth, about 12,000 kilometers in diameter.
Earth is the largest of the 4 inner rocky planets, and as of right now, it is the only world known to support life. We are a blue planet covered in an abundance of liquid water. An average surface temperature of a mild 15 degrees, as well as a number of other environmental factors, has led to the Earth being filled with life. Regardless of the climate, hot, cold, low, high, life thrives. By far the most unique planet in our solar system.
These are the gas giants, the smallest of which is Neptune. Now Neptune is about 49,000 kilometers in diameter. It's huge.
Neptune is the most distant planet from the Sun. Discovered in 1846, it has only recently completed a single orbit around the Sun, with one orbit taking the equivalent of 165 Earth years. Neptune gets its colour from the methane in its atmosphere. It absorbs the red light from the Sun but reflects the blue. The winds on the planet can reach 1,300 miles per hour, almost twice the speed of sound. And due to the intense pressure on the planet, it can lead to hydrogen and carbon forming diamonds that rain down.
And it's soon followed by Uranus, which is 51,000 kilometers in diameter. Uranus is special because as most planets rotate clockwise, Uranus rotates on its back.
Uranus is a gas giant. A collision with a planet-sized body has knocked it sideways, meaning each side of the planet now faces the Sun for 42 years at a time. It was only discovered by William Herschel in 1781 and named Georgium Sidus, in honour of King George III. However, it was later renamed by astronomers to Uranus, after the god of the skies.
Then we have the jewel of the solar system, Saturn. Now Saturn is about 128,000 kilometers in diameter, but if you account for the rings that go around the planet, it would technically be 250,000 kilometers. But we don't do this since there are actually satellites orbiting the planet. We only count the big bit in the middle. Now if I was to ask you to name a planet in our solar system other than the Earth, the first one that probably comes to mind is Saturn. Saturn is the gem of the solar system. No other planet is quite like it. The other gas giants also have ring systems going around them, but Saturn's are unique and beautiful.
Saturn's rings are made from billions of fragments of ice and rock. The rings extend beyond twice the diameter of Saturn, but on average they have a thickness of just 10 meters.
One of the more interesting things about Saturn is the density of the planet itself. Now all the gas giants are made up of the main gases such as nitrogen and methane, but Saturn is filled mainly with hydrogen and helium. And what this means is it's less dense than water. So if you had a body of water large enough to contain a planet and place Saturn in it, it would float.
Saturn was recently classed as having the most moons in the solar system. As of now, Saturn has 82 moons caught in its orbit, but that's likely to change as we discover even more.
Which then leaves us with the god of the planets, Jupiter. Now Jupiter is about 142,000 kilometers in diameter, which is about 12 times that of Earth. In terms of volume, Jupiter could swallow planet Earth 1,321 times. And you see this great red spot on the surface of this planet. It's a storm that's been raging on for almost 400 years. That could swallow the Earth 3 times whole. Our entire planet would be consumed by this storm 3 times.
If you were to take all of the mass from every other planet in the solar system and add it all up, Jupiter would still weigh 2.5 times more. It has the shortest day in the solar system, as well as 4 of its largest moons. These are the Galilean moons, each of which is a wonder in its own right. It has no solid surface, only an extremely thick atmosphere. If Jupiter had been made up of about 50 times more hydrogen, it's likely it would have become a star. Jupiter is very large, especially when compared to the Earth, but it is nothing when compared to the biggest body in our solar system, the Sun.
So just how big is the Earth compared to the Sun? Well, the Earth's about 12,000 kilometers in diameter, and the Sun is 1.4 million kilometers. That means you could fit about 1.3 million Earths inside just one Sun. So to put that in perspective, say the Earth was about this big, then the Sun would be the size of the London Eye.
The Sun is an enormous ball of hot, luminous gas. At its core, hydrogen atoms are converted into helium, releasing energy in the process that is felt here on Earth. It has existed for 4.6 billion years and will likely survive for another 5 billion. The Sun alone accounts for 99.8% of the entire solar system's mass. On the surface, temperatures are 5,500 degrees, whilst at the core they reach 15 million degrees. Despite the immensity of the Sun, it is just an average sized star. There are plenty out there that are far, far bigger.
Now the Sun has been around for a very long time. 4.6 billion years is tremendous, especially when you compare it to the life of a human. We on average live for 80 years. So talking about something that lasts in the order of billions of years is very hard to comprehend. The age of the universe is 3 times older than our Sun. So, in order to make it easier to understand, this is the cosmic timeline. 13.7 meters, representing 13.7 billion years of history, where every meter is a billion years and every centimeter is 10 million. Where do we start? The beginning of time and space itself, the Big Bang. However, it wouldn't be until 200 million years later that the first stars were born, and the universe was no longer in darkness. And it wouldn't be until 11 billion years ago that our own Milky Way galaxy would come into existence. Where are we? We're still not born yet. Our own Sun is a 2nd or 3rd generation star, which means it was formed from the ashes of 1, maybe 2 dead stars. This is the birth of our solar system. Now at this point in time, the universe is 9.2 billion years old, which means for us, relatively, we are very young compared to the age of the universe. In the early stages, things were chaotic. It wouldn't be until a billion years later that the first signs of life would form on our planet. Now there's much debate about how life formed. Some believe it came from an asteroid elsewhere in the galaxy that carried the ingredients for life. Others believe it started at the bottom of the oceans around hydrothermal vents. Regardless, the first real species of animal, the fish, weren't born until just 500 million years ago. 375 million years ago, Tiktaalik became the first creature to leave the oceans and venture onto the land, paving the way forward for many new species, including the amphibians, reptiles, dinosaurs, mammals, and birds. For the dinosaurs, their dominance was unchallenged and relentless for millions of years. Until 65 million years ago, disaster struck when an asteroid wiped out all of the non-avian dinosaurs, meaning the Earth was now up for grabs to those who were left on it. Amongst them were the mammals. They scurried around at night in fear of the dinosaurs, but now they saw their chance and they took it. They made the Earth their own. But in order to appreciate this small of a point in time, we're going to have to make our timeline bigger. How much bigger? Well, it now needs to be long enough to go around our entire planet.
On our current 13.7 metre timeline, each metre represents a billion years. But if we stretch it out so it's long enough to go around our entire planet, then on this new timeline, each metre represents just 342 years.
Now on this scale, we have now and 4,500 years ago. What happened 4,500 years ago? Well, we invented the alphabet, as well as the wheel. Soon after, Buddha was born, followed by Christ, the invention of zero, Muhammad, and then just over 500 years ago, the two sides of the planet became aware of each other as Christopher Columbus sailed the Atlantic. Copernicus told us that we weren't at the centre of our solar system, the sun was. Galileo discovered Jupiter's 4 largest moons. Newton released his Principia of Mathematica. At the start of the 20th century, the Wright brothers developed the first airplane. Ernest Rutherford discovered the atom. Edwin Hubble, the first galaxy. And perhaps most important of all, 50 years ago, man left footprints on another world for the first time. And by no means the last. Now when you scale things back to the previous timeline, showing all 13.7 billion years of the universe's history, we take up a very thin margin of it. In fact, the history of our entire civilization can be represented on this scale by the same thickness as 1/10 of a human hair. It's so small you can't even see it with the naked eye. But for me, the most interesting point in time is not on this timeline. It will be on the next one. The next 1/10 of the thickness of a human hair. Think of how far we've come in the past few thousand years, and just how much further we'll go in the next couple of thousand. Assuming we don't destroy ourselves, we will venture to new worlds. Perhaps in the next few thousand years, we'll answer some of the universe's biggest questions. Is it really 13.7 billion years old? And is this the only universe out there? What an astonishing question, asked by a species that was formed from the ashes of a dead star. I'm Damon Scotting, and this was Astronomical. Light is the fastest thing in the universe. Nothing can travel faster than the speed of light. It's the cosmic speed limit. In just 1 second, light could travel around the entire globe 7.5 times. And although we may think of it as being instantaneous, it's not. Like all things, it has a finite speed. And it's because of this that everything we see is in the past. I'm Damon Scotting, and this is Astronomical.
I'm here in Shanghai, where one of the world's greatest light shows takes place. A permanent fixture in the Shanghai skyline is the Bund Tower. Roughly 600 meters away from where I'm standing, I am seeing it in the past. Because of the finite speed of light, there is a time delay.
Across the river there, that's the Bund Tower, and that is approximately about 600 meters away from me. Now the speed of light is 300,000 kilometers per second. So when you do 600 meters divided by the speed of light, which is 300,000 kilometers per second, you get roughly 2 microseconds. That's the time delay between the time it takes for the light to bounce off that tower and reach my eye. So I'm seeing that tower right now as it was 2 microseconds ago. So the effects of light may seem insignificant on Earth because we deal with such small distances. It's impossible for our brains to comprehend the time delay. But what about when we look towards the skies? What about when we look up at the moon? Now the moon is 384,000 kilometers away. And because light again travels at 300,000 kilometers per second, we can do the distance to the moon, 384,000 divided by the speed of light, 300,000 kilometers per second, and it gives us 1.26. That's the time delay. And we calculated that when the Apollo astronauts put retroreflectors on the surface of the moon. What that allowed us to do was bounce lasers off those retroreflectors on the moon and then receive them back on Earth. And the times we got were roughly 2.52 seconds, depending on how close the moon was to the Earth, because it changes throughout the year. And 2.52 seconds is 1.26 multiplied by 2. So what you've got is the time it took for the laser to reach the moon and the time it took for it to come back.
Moving even further out away from our planet, we reach the Sun. Now the Sun is 150 million kilometers away, which means it takes light 8 minutes and 20 seconds to reach us. So if our Sun was to disappear, we wouldn't notice it until 8 minutes and 20 seconds later. Nor would we notice being flung out into space because we were no longer in orbit around the Sun. So at 8 minutes and 20 seconds, the distance delay is starting to become noticeable. Now what happens if we look out towards the other stars in our universe? Take our nearest neighbour, Proxima Centauri. It's 4.26 light years away, which means if you're travelling at the speed of light, for 4.26 years, you would then eventually reach it. So if you're travelling as fast as you could possibly go in the universe, you still wouldn't reach our nearest star for 4.25 years. Things get even stranger when we look further out. There's one star in the constellation of Orion that may already be dead.
Do you see that bright red star just here? This is a super red giant. It's called Betelgeuse, meaning shoulder. Now Betelgeuse is about to go supernova. In fact, it may do so anytime from now till about 1 million years or so. It's hard to predict. But the point is, it could go supernova any second. In fact, because Betelgeuse is 430 light years away, there's a fair chance it may have already gone supernova. But the light hasn't had a chance yet to reach us. Which raises the question, are we right now looking at a dead star? Has Betelgeuse already went supernova and the light hasn't had a chance to reach us? Maybe. Betelgeuse may have went supernova 429 years, 364 days, 23 hours, 59 minutes and 45 seconds ago. And if it did, then that means it's about to go supernova now. 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 How cool would it be if I shot a laser at a star and it blew up? It's not my dream. Yeah, anyway, for any time from now to 1 million years or so in the future. So maybe it would... One can dream of blowing up a star with a 10-pound laser. Anyway, we move on. Do you see that faint fuzzy patch of light? That's not a cloud. That is an island. An island containing over 1 trillion stars.
That is the Andromeda Galaxy. It's 2.5 million light years away, which means the light from this galaxy has travelled unimpeded through the vacuum of space for 2.5 million years, up until the point it hit the sensor of my camera, and now I've captured it. This is an image 2.5 million years old. The Andromeda Galaxy is the most distant object you can see with the naked eye. Okay, it's just incredible. It's incredible what you can do with just a camera. The Andromeda Galaxy isn't something that comes around once a year or once a decade. It is there 365 days. It doesn't go away. It's not something you have to pay to see. It's just there. When you go out and look up at the night sky, it's a free show. And it's possibly the best show in the world when you can see things like this. Over 1 trillion stars. Maybe there's someone, or maybe there's something orbiting around one of those stars who's looking back at us. This is my image of the Andromeda Galaxy. Now, there are over trillions of stars in this image, which means trillions of solar systems. So the idea that maybe in 2.5 million years' time, there is some other sort of being that's looking back at us and taking a similar image of the Milky Way is just mind-blowing. Or maybe in fact, they did the exact same as what I've done tonight 2.5 million years ago. It truly is incredible the detail that can be made out with just a simple camera. But with the right tools, even more extraordinary images can be achieved. This is a gigapixel image of the Andromeda Galaxy. It is the highest resolution image ever taken of it. At this level of detail, this ocean of stars can be resolved to reveal trillions of individual points of light. At this scale, every single point of light is an entire solar system, as it looked 2.5 million years ago. Because the galaxy is so far away, it is as though you are travelling back in time to see things as they were. Time travel might seem like something straight out of science fiction, but it's not. Time travel is real. In fact, you and I can both do it. Everyone can do it. And I'm going to show you how. There's 2 ways to travel in time. The first of which is to move. To have a velocity of any sorts, you are travelling in time relative to an observer. The second is to be near a body of mass. That's it. That's all you gotta do. By being on this planet, near the Earth, on its surface, you are travelling in time. Now it may look confusing, but I promise you it's not. In fact, in the next 60 seconds, you will understand how to travel in time. So, we have 4 variables. T prime, just here, is the time at which the observer, me, experiences time. T is the time at which our target will experience time. They are going to be the one moving. They're going to be the one time traveling. And then down here we have V for velocity, the speed at which they're moving, and C represents the speed of light, which is roughly 300,000 kilometers per second. It's very fast. For me, sat here watching them, I've experienced 1.0000000000000000002 seconds, whilst they've experienced just 1. I really hope that's the right amount. Okay. So as they walk past, every second that goes by, I experience it 20 attoseconds slower than they do. They are travelling forward in time. For them, they've only aged 1 second. For me, I've aged an extra 20 attoseconds. But 20 attoseconds is incredibly small. It's almost insignificant. It's 2 times 10 to the power of minus 17. That's 0.1602. But what if they were to move faster? What if they were running? Now the fastest a human can run is just over 10 meters per second. But even then, the time difference that me
and they experience is still so small. Now what if I was to take a ride on the bullet train?
Now at these speeds you are moving very fast, but relative to the speed of light, this is almost nothing. In fact, if you were moving at this speed for 1,000,000 years continuously, you'd only experience 2 seconds time difference to a stationary observer.
The faster you move through space, the slower you move through time. The closer you approach to the speed of light, the slower time passes from your perspective. So to really appreciate the time dilation going on here, we're going to need to approach speeds much closer to the speed of light.
The time delay you experience increases exponentially the closer and closer you get to the speed of light, until you do eventually reach the speed of light itself and time stops.
Now this is the equation for time dilation based on your proximity to a body of mass. The closer you are, the slower time moves from your perspective. The larger the mass itself, the more time is dilated from your perspective. And the same applies here on Earth. The closer you are to the center of our planet, the slower time moves. Right now I'm on the surface, but if I was to go up a mountain or even a hill, time would tick faster than it would down here on the surface. And I know it sounds crazy to imagine this, and the numbers themselves are incredibly small, but trust me, even your head is slightly older than your feet because of this time dilation. But for this sort of time dilation, things start to get really interesting when you get near a body of extreme mass. I'm talking about the densest objects in the universe. A black hole. Another way to make time move slower for you is to go somewhere where there's a strong exertion of a gravitational pull. And there's no place in the universe where there's a stronger gravitational pull than around a black hole. In fact, there's a region around a black hole referred to as the event horizon, where the gravitational pull is so strong that not even the fastest thing in the universe, light, can escape its pull. And if you were to reach that point, if you were to reach the event horizon surrounding a black hole, time would literally stop for you. It would be the end of your universe. Time travel into the future is possible, but time as we know it right now only flows in one direction. You can't travel back in time, but you can travel forward.
There is no way to travel back in time, but there is a way to look back into it and see previous events, even events that happened billions of years ago. This is a time machine. A telescope is a time machine. The mirrors inside them are like buckets. They capture light from distant objects. The bigger the mirror, the more light you can capture. There's one telescope that has captured the most distant light we've ever seen. And it's also the most famous. This is the Hubble Space Telescope.
7, 6, 2, 1, and liftoff of Spaceship Atlantis. Final visit against the Vision Hubble into the deepest grandeur of our universe. Houston, Atlanta, small program with the FCS channel.
Hubble launched 30 years ago, carrying the hope and wonder of our entire species. However, disaster struck just weeks into its mission when the world's most precisely cut mirror was noticed to have a small defect on its surface, just 200 nanometers long. Problems like this weren't planned, but they were prepared for. Hubble was placed in a low Earth orbit, meaning potential repair missions were possible. This is footage from the final mission to service Hubble. In total, Hubble underwent 5 repair missions. It will likely function until 2030 before it slowly falls in its orbit around the planet and burns up in the atmosphere before it can reach the ground. But the images it achieved in its lifetime have changed our entire perspective towards the way we see the universe. Hubble has taken some of the most remarkable images in human history, one of which is significantly more important than any other.
Now this may be the most important image taken in the history of mankind. This is the Hubble Ultra Deep Field. Now the reason this image is special is because the Hubble Space Telescope pointed at an area of the sky that was seemingly blank, nothing inside of it. And what it found after exposing itself for just over 10 days was that there are 10,000 galaxies hidden away in this tiny little area.
What looks to be a tiny blank region in space reveals the true immensity of the scale of the universe. This image takes up an area 1/30 millionth of the sky, but its capabilities are still limited. Einstein showed us a century ago that gravity distorts light, and because of this bending effect it can magnify objects nearby, causing them to appear 10 to 20 times larger than they otherwise would. It's because of a group of several hundred galaxies named Abell 2744 that we are able to see one very special galaxy due to this gravitational lensing. This is GN-Z11, the furthest known galaxy in the universe. It is one of the very first collections of stars to ever form, and it would have looked very similar to this. Hubble has taken us to the very edge. It's allowed us to look back to just 400 million years after the beginning of the universe. But soon there will be a new space telescope that will allow us to see even further back into time. This is the James Webb Telescope. It is the largest and most advanced space telescope ever made. With it, we hope to see the very first light of the universe. Its precise resolution will allow it to resolve a penny from a distance of 40 kilometers. It was scheduled to launch in 2007 with a budget of $500 million, but due to a number of different factors, the costs of the telescope are now at $9.6 billion, with an expected launch date of March 2021. Its primary mirror is an enormous 6.5 meters, making it far larger than Hubble's at only 2.4. Whereas Hubble made most of its observations in visible light, James Webb is designed for infrared. Infrared observations are far superior when looking for older stars and galaxies, as they penetrate dust and gas clouds far better. Its infrared capabilities are expected to allow it to see the very first galaxies that formed just a few 100 million years after the Big Bang. The James Webb will also be an excellent addition in our search for exoplanets that may harbour life. The telescope's capabilities allow it to analyse the spectroscopy of a star's light that passes through the atmosphere of a planet, telling us its composition and if it is able to harbour life. The mirror is too big to fit inside the spacecraft that will launch it from the surface of the planet, so it needs to be folded. It also features the largest sun shield ever flown. 5 layers, the size of a tennis court, will protect the telescope from the heat of the sun, earth and moon. One of the biggest reasons Webb is taking so long to launch is because of where it's being placed. Hubble was in a low Earth orbit just 540 kilometers away, whereas Webb will be placed in Lagrange Point 2, 1.5 million kilometers away. L2 is a point in our solar system where bodies experience equal gravitational pulls from the Earth and the Sun, thus moving in a constrained orbit, effectively around the Sun itself at the same speed the Earth does, despite being further away. The telescope will be pointing away from the Earth, Sun and Moon, protected by its sun shield, operating at a cool temperature of minus 220 degrees Celsius. The telescope will be making observations in infrared, so it's key that there is no distortion from anything nearby.
Now the James Webb Telescope has faced many setbacks. But it won't be long now before it does launch. And when it does, it's likely it will prompt questions we never thought to consider before. It will reveal wonders about the universe that we couldn't have possibly imagined without it. The James Webb Telescope is the ultimate representation of all that it means to be human, to be curious, to wonder, to have a relentless desire to know more. And I, for one, cannot wait for what it will show us. I'm Damon Scotting, and this is Astronomical. Was astronomical. When we look up at the night sky, we can see roughly 6,000 stars with our naked eye. However, this number is just a fraction of the real number of stars in our galaxy alone. The Milky Way is home to 1 trillion stars, and it's just one average-sized galaxy in a universe containing 200 billion others. Which means out there are 200 billion trillion stars. So it begs the question, are we alone? I'm Damon Scotting, and this is Astronomical. Now in astronomy, we often use the numbers millions, billions and trillions. But these are huge numbers. We don't use them in everyday lives. Except for when Chris buys 4.2 billion apples and Paige needs to borrow 168 million. But even then, that's only on maths tests at high school. So in order to make you understand how truly large the numbers in astronomy are, I'm going to write it out for you. So, in our galaxy alone, there are 1 trillion stars. A lot of stars. How many exactly? Well, that's 1 with 12 zeros after it. 4, 5, 6, 7, 8, 9, 10, 12. That's how many stars there are in the galaxy, the Milky Way galaxy. 1 trillion. 1 with 12 zeros after it.
The number of stars in our galaxy is immense. It isn't possible to simply look up at the night sky and count all the stars. So the total number in our Milky Way galaxy could be anywhere between 100 billion to 1 trillion.
Now that was just the stars in our galaxy alone. And ours is just an average sized galaxy in a universe containing 200 billion. Now that's 2 with 11 zeros after it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how many galaxies there are in the universe.
Although a smaller amount, the number of galaxies is far harder to predict. Despite being hundreds of thousands of light years in diameter, most galaxies are invisible to us. They are beyond our current scope. Some are so far away and dim that we don't currently have the necessary tools to see them. The number 200 billion comes from an average based on the Hubble Deep Field. The image represents 1/32 millionth of the night sky, and there were roughly 5,500 galaxies within it that we could see. So 5,500 multiplied by 32 million means there are almost 200 billion galaxies in the observable universe.
So that's 1 trillion stars in the average galaxy. And there's 200 billion galaxies in our observable universe. So that means the total amount of stars in our universe is 2 times 10 to the 23. That's 2 with 23 zeros after it. Okay, so that's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's it. That's how many stars there are in the observable universe. And we're just one. 1 in 200 billion trillion. And there it goes, washed away in a matter of seconds. And that's all we are. We are just a drop in a vast ocean. We're a grain of sand on an endless beach. We're nothing. On the grand scale of the universe, we are tiny. And there's two things you can do about that. Number one, you can feel scared. You can feel worried by the fact that we may be alone in this great, vast space. And if we're not alone, maybe that's even scarier. Or you can grab it by both hands. You can make the most of the fact that we might be the only life out there. We are precious. We're unique. We are special. And we need to make the most of that.
Now 200 billion trillion stars is an astronomical figure. It is far beyond the comprehension of any human being. The potential for life seems to be limitless. So the question is, where is it?
Now, given the vast amount of stars in our universe, it seems difficult to believe that our planet is the only one capable of supporting life. So how do we discover new worlds that are similar to our own? Well, when we look up at the night sky around different stars, we observe a region known as the Goldilocks zone. This is a point around a star where the temperature isn't too hot and it's not too cold. It's just right. Now, if a planet is too close to its star, liquid water wouldn't last long and would boil away from the surface. That is true for Mercury and recently Venus. In fact, in the early stages of the solar system, just a few hundred millions of years after the birth of our sun, Venus was believed to have once had liquid water on its surface. But back then, the sun was 70% of its size that it is today. So as it grew in size, the water evaporated. And as it did, it added water vapor to the atmosphere, which led to a runaway greenhouse effect on the surface of Venus, which turned it into the hellish world we know today. Then, going out towards the edge of the solar system, we reach Mars. Now, Mars is far too cold for liquid water to exist on its surface. Although it can have temperatures as high as 27 degrees Celsius, on average they're around minus 60 degrees. And we can see from the surface of Mars that there was once riverbeds where water flowed, but now they are dry. Which leaves us with our planet, planet Earth, where the temperatures are just right for liquid water to exist. And indeed, life does thrive here. So now we know where we should be looking around stars for the right kinds of planets that could harbour life. How do we spot them? How do we know which stars have planets? After all, planets don't give off light. They merely reflect it. And stars are incredibly bright. So how do we detect exoplanets? How can we find planets that orbit around other stars? After all, stars are very bright, but the planets that orbit them give off no light whatsoever. So rather than look out for points of light, we look out for the absence of it. By measuring a star's brightness over a long enough period, we notice dips. These dips occur when the planets orbit in the right plane to us here on Earth. And by measuring the intervals at which they occur, we can determine the size of the planet, the distance it is from its star, the length of its year, and most importantly, whether or not it could harbour life.
Given this information, it seems rather easy to determine whether or not there are habitable worlds orbiting a star. This method of discovering exoplanets has proven successful ever since the first detection was made back in 1992. As of the 1st of May 2020, there are 4,260 confirmed exoplanets in over 3,000 systems, with 22% of those systems having more than one planet. We have still only analysed a very small portion of the stars in our own galaxy, but the results so far are extremely promising. So if there really is life out there, why haven't we heard from it?
So now that we know that there's potentially alien life out there nearby in the galaxy, how do we communicate with it? How do we make contact? Our best method is probably through radio waves, which travel at the speed of light through the vacuum of space. But our nearest star, Proxima Centauri, is 4.26 light years away from us. That means even sending a signal as fast as the speed of light, it will still take 4.25 years before it reaches our nearest exoplanet. Assuming it has life and they have the abilities to respond and send another message, we wouldn't know for another 4.25 years. So from the time we sent our initial message saying a simple hello, it'd be 8.5 years before we got a reply back. So it's very hard to communicate over the vastness of space. But what about intelligent civilizations getting into contact with us? Have we ever picked up a signal from another species? Well, on August 15th, 1977, something very strange happened. A man named Jerry Damon picked up an unusual signal using the Ohio Big Ear radio telescope. Now in the 50s, astronomers decided that if an intelligent life form was to communicate with us, they would do so on a very specific frequency, 1420 megahertz. Now this is special because its wavelength is 21 centimeters, which is the same as that of hydrogen, the most abundant element in the universe. So they set aside this frequency, and only they could specifically communicate at this wavelength. They pointed their radio telescopes towards the constellation of Sagittarius, and they listened out. Then, on August 15th, 1977, 2 days after the measurement was taken, Jerry Damon analysed the measurements, and to his bewilderment, he discovered this anomaly. He wrote down 3 letters next to it. This is the WOW signal, and it's still today our strongest evidence of communication from alien life. But it was almost 50 years ago, and since then we have pointed far more sensitive telescopes towards the same region of the sky, and we're yet to hear anything back. One of the beautiful things about science is that we don't just take things as a given. In order for things to be considered as true evidence, they must be repeatable. So sadly for now, the WOW signal is just a one-off. But one day, we will pick up another one. Maybe from the same region, maybe not. But this is encouragement to keep on listening out.
There's plenty of reason to believe there is life out there in the universe. But the real question is, are they intelligent enough to communicate with us?
So what is the likelihood that we are all alone in the universe? Out of the 200 billion trillion stars there are, we are all there is in terms of intelligent life. There are believed to be more stars in the observable universe than grains of sand across all of the Earth's beaches. So can we really be the only form of intelligent life out there? Well, one man decided to try and answer this question. This is a Drake equation, developed by Dr. Frank Drake, one of the founding fathers of SETI, the search for extraterrestrial intelligence. It determines how many intelligent civilizations there are in our galaxy that we could discover today. And it starts off with the number of stars that are formed every year in our galaxy. The next variable is the number of those stars that have a planet orbiting them. We believe this number to be 100% or very close to it. This is followed by the number of those planets that are capable of developing life. Then the number of those planets that are capable of developing intelligent life. Those of which will be able to communicate with us. And then finally, perhaps most importantly, the longevity of those forms of life. How long the civilization will last before wiping itself out. Now this is very hard to determine because we have nothing to base it on. And if we try and base it on ourselves, the number is very low. Because as an intelligent species that's been able to communicate, we have existed for the blink of a cosmic eye. Now this equation is often the topic of hot debate, because all the variables can give a wide variety of answers. A pessimist would say there are no other forms of intelligent life out there in the universe. Whereas an optimist might look at this and determine that civilizations could last in the order of billions of years, in which case there could be trillions of planets in our universe. Trillions of other forms of intelligent life able to communicate with us. A vast network. And if that's the case, the universe is a very exciting place. And it might seem scary that there's lots of different forms of life out there, but it might seem even scarier that there are no forms of life out there, and that we are all alone.
If we are not alone, then the next question is, what would other forms of life appear as?
So what do aliens actually look like? Well, in the movies, they're depicted in a variety of different ways. They often have a large number of legs, arms, eyes, and most importantly of all, a big brain. I've asked people to send in a few of their designs of what they think an alien looks like. And a general trend is that they're usually green people with lots of arms and lots of legs, as well as plenty of eyes and often tentacles. This is a design that my best friend Paige did. And as you can see on her world that is covered in burgers and nugget trees, the species that live on here have a variety of legs and arms. But there's a strong reason to believe that aliens might not be so dissimilar to us as we might think. The reason they stretch our imagination is because we've never seen them before, and we imagine them to be complex beings. But in reality, they need to be the same as us in order to survive. In fact, there's a number of things you will likely need in order to succeed and top your planet's food chain. The first is an exoskeleton protecting the brain, the most important organ. The second is manipulative digits like fingers. These will allow you to hold tools. Binocular vision to judge distance. Between our eyes there is a parallax, so having two or more eyes allows you to tell how far away something is. The number of legs, arms and eyes is also very important, because too many will overload the brain. It will not allow it to focus on other areas. It is likely that if we discover another alien species, they will have more similarities than differences to us. No legs would lead to mobility issues. One leg would lead to balance issues. Two legs is just about right. The same with two arms. And two eyes allows you to have binocular vision. So depending on the way you look at it, we might be the bare minimum you need. Or we might be too much. If we were to discover another alien species, then they might look similar to us. But if one was to discover us and venture through interstellar space, then it might be very different. The vacuum of space is a very harsh environment. We wouldn't last more than a couple of minutes in it. But when traveling through it, the spaces between stars is so vast that even traveling as fast as you could possibly go at the speed of light, it will still take you years to reach your nearest star. Which means in order to do so, you need to adapt to your environment. So it's likely that these cosmic voyagers who are visiting our little blue planet will have done so. Now the question, are we alone, is possibly the most profound question you can ask in science today. It is one that has not only puzzled scientists, but possibly every single human being to ever walk the planet. I can guarantee that at least once in your lifetime, you have looked up at the stars and wondered if there was life elsewhere, or if we are in fact all there is. And if you were to answer that question today, based on the evidence we have, then the answer would be a resounding yes. We are all alone. We are yet to find life elsewhere in our solar system, let alone the universe. And it might seem arrogant or maybe even ignorant to assume that we are all there is. But as a species, we are still very young. And we've explored so little. One day, in the future, we may receive another signal like the WOW signal. One day, we may venture to another solar system. One day, we may encounter alien life. And the knowledge we gain from those experiences will shape how mankind goes forward forever. We orbit around an average-sized star, which makes up an average-sized galaxy, which itself might make up a smaller than average-sized universe. It's possible that our universe is a mere drop in a sea of other universes. So I'll let you answer the question. Are we alone? I'm Damon Scotting, and this was Astronomical. A mountain 3 times the size of Everest. A storm big enough to engulf our entire planet multiple times. And a moon with more volcanoes than the whole planet itself. These are just a few of the wonders of the solar system. I'm Damon Scotting, and this is Astronomical. Now this one's a mammoth. Okay. If I was to ask you, what's the tallest mountain on Earth? Then you'd probably say Everest. And you'd be right. Everest measures to almost 9 kilometers tall from sea level. But what if I was to ask you, what is the tallest mountain in the solar system? Well, then you could use basic logic to rule out the 4 gas giants, because they can't have mountains, because they have no solid surface and the pressure is far too high for them to venture up, which leaves you with the 4 inner rocky planets: Mercury, Venus, Earth and Mars. Now Mercury's small, bombarded with asteroids constantly, no big mountains. Venus, Earth's hot sister, not so much. Venus has a similar problem to the gas giants, the surface pressure is far too high. Which leaves you with Mars as the only other potential candidate. Now Mars is almost half of Earth's diameter, but that may work as a benefit. Because Mars is a lot smaller, it has a lower surface pressure, allowing things to venture a lot higher from the ground. And indeed, Mars does have the tallest mountain in the solar system. It's called Mount Olympus, and it's 2.5 times taller than Everest. Now, as we know, Everest is the tallest mountain on Earth. It's almost 9 kilometers high, but Mount Olympus is over 21,000 kilometers high. That's 2.5 times larger than Everest. So to put it into perspective for you, if this right here is Everest, then that makes this Mount Olympus.
One of the main differences between the two is that Olympus Mons is a shield volcano, which means it has a very small slope, roughly 5 degrees on average. It's because of this, and Mars' smaller size compared to the Earth, that if you were to stand on the summit of Olympus Mons, you wouldn't even notice you were standing at the top of the solar system's tallest mountain, as its base would extend well beyond the horizon. Its total surface area is slightly more than that of the entire United Kingdom. It is a true wonder of the solar system. Jupiter is the god of the planets. Not only is it the largest in our solar system, it's also home to the biggest storm we've ever seen. This is Jupiter's Great Red Spot. It is an enormous anticyclone which has been allowed to grow to such a size because Jupiter has no landmass, meaning unlike Earth, there's nothing to slow the storm down. Voyager 1 was the first spacecraft to get up close enough to Jupiter to witness the truth about this atmospheric monster. When it was first discovered just over 400 years ago, it was 3 times the size of Earth, a storm big enough to engulf our planet multiple times. But over the past few centuries, the storm has been shrinking, and is now only just a bit larger than our planet. We're not sure exactly when it will disappear, but one thing is for certain, that even at its ever shrinking size, Jupiter's Great Red Spot is still a colossal storm that could swallow our entire planet. Perhaps it is temporary, but for now, it truly is a wonder of the solar system.
So when we talk about the solar system and the planets within it, we split them into two categories. The inner rocky planets, Mercury, Venus, Earth and Mars, and then the outer gas giants, Jupiter, Saturn, Uranus and Neptune. Now the inner rocky planets are very close to the Sun. In fact, the furthest one is Mars, and even then at any given point it's still within 2 astronomical units of the Sun. So we'll say that bit of seaweed right there, that's the Sun, not to scale. And then the closest one is Mercury, which is soon followed by Venus. Then we have our planet, planet Earth, and then a bit further out we have Mars. These are the 4 inner rocky planets. But then Jupiter doesn't come into play until 3 astronomical units later. So Jupiter is all the way out here. So what lies in this great gap? Is there anything at all, or is it like most of space and completely empty? Well, this is where the asteroid belt lies. Now the asteroid belt is a collection of millions of tiny little pieces of rock, some the size of a particle, others the size of almost 1,000 kilometers. And it stretches all the way around the Sun in one complete orbit. Now if you take all of the asteroids, everything in the asteroid belt itself, and add all its mass up, it still only comes up to half of that of the Earth's moon.
The term asteroid comes from the Greek word asteroidus, which means star-like. Even the largest asteroids still can't be resolved through a telescope in the same way a planet can be. Instead, they appear as bright points of light in the sky, like the stars. Within the asteroid belt there are 1.7 million asteroids that are larger than 1 kilometre. But despite there being so many huge rocks, the odds of a collision are less than 1 in a billion. This is because in reality the asteroids are actually really far apart from one another. The asteroid belt is composed of the leftovers from the formation of the solar system when the planets were still coalescing to form the large bodies we know today. There is not enough mass in the entire asteroid belt to form a small terrestrial planet. And even if there were, it still would be very difficult to do so, since Jupiter's gravity prevents the asteroids from forming a much larger body the size of a planet.
So the majority of these are tiny. In fact, the biggest object in it is called Ceres. Now Ceres is a dwarf planet. It's still less than 1,000 kilometers in diameter, which means it's smaller than the Moon.
Ceres is the most water-rich body in the inner solar system other than the Earth. We still know very little about the asteroid belt. Some theories about the evolution of life base themselves on the idea that it started here on Earth thanks to an impact from an asteroid that contained the ingredients for life. So perhaps there are still wonders waiting to be discovered within the asteroid belt.
Now Jupiter, as well as being the largest planet in our solar system, also has the most amount of moons. In fact, the current total of moons orbiting Jupiter is 72. However, we're going to look at 4 in particular, Jupiter's Galilean moons. Now these moons were discovered in the 1600s by Galileo himself. They were seen as 4 bright points of light orbiting around the planet at regular intervals. They're known as Ganymede, Io, Callisto and Europa. Ganymede is the largest of these moons, and it's also the largest moon in the entire solar system. So big, in fact, it's bigger than the planet Mercury.
Ganymede is far larger than our own moon, and in terms of volume, it could fit exactly 12 of the dwarf planet Pluto inside of it. If it wasn't orbiting Jupiter, but instead the Sun at the same distance as any of the inner rocky planets, then it would easily fall under the classification of a planet.
Then we have Io. Now Io is the most volcanic world in our solar system. There are more volcanoes on the surface of Io than there are on the whole of planet Earth.
Io is a hellish world. Upon its surface lie countless scars. It is the innermost of the Galilean moons, which means it is a tortured world. It's in the middle of a tug of war from Jupiter and the other more distant moons. Like most bodies, its orbit is slightly eccentric, which means it's not a perfect circle. Instead, it's more like a squash circle, which leads to points in its orbit where it feels a stronger gravitational pull from Jupiter, and points where it feels less. This causes the moon to contract and expand in a process known as tidal heating. The moon's crust is constantly being broken, leading to cracks appearing and volcanoes forming on its surface. When the first images came in of Io, scientists weren't certain what to expect. In this photo, many assumed that there was another moon behind Io in the distance. But it was only when an engineer pointed out that this was no moon. It was a volcanic plume. The volcanoes on Io's surface were active. Intense lava flows across the surface of Io. A truly bizarre world.
Then we have Europa. Now Europa's surface is frozen, but beneath it lies oceans of liquid. In fact, there's more liquid on the moon Europa than there is on the whole of planet Earth.
Europa is classed as one of our best chances of finding life elsewhere in the solar system. It has a frozen surface, but trapped beneath it there are oceans of liquid water, more than on the whole of Earth. Europa has an even more eccentric orbit than Io. The constant stretching and relaxing of the moon causes geysers to erupt from the surface, firing ice particles high up into the atmosphere.
And then lastly we have Callisto, the second largest of the Galilean moons, mostly featureless.
Callisto is almost the exact same size as the planet Mercury, but it only has 1/3 of the mass. It is the most distant of the Galilean moons, and its heavily cratered surface is one of the oldest landscapes in the solar system. The Galilean moons are each more different than the last. They collectively have a vast number of curiosities that have left scientists very eager to explore these wonders in more detail. Saturn's rings are in their own right a wonder of the solar system. They are made up of billions of fragments of ice and rock, which encircle Saturn with an enormous diameter of 280,000 kilometers, more than twice the planet's diameter. But even more astonishing is their thickness, on average, is just 10 meters. However, the real wonder isn't one of Saturn's rings. It's what lies buried in Saturn's most outer ring. In recent decades, discoveries about this wonder have made it the most intriguing world in the entire solar system. This is Enceladus. Enceladus is a fresh moon. It is only 500 kilometers in diameter, but is the most reflective body in our solar system, reflecting 90% of the light. Beneath the surface of ice lies oceans of liquid. At the bottom of these oceans are hydrothermal vents. The temperature difference between the cold surface and the warm core causes cracks to appear and geysers form. Hot jets of ice erupt from the moon's surface. Now on Earth we also have geysers, but here they only erupt to heights of 20 meters. On Enceladus, where the surface gravity is far less, the plumes of ice reach heights of 1,000 kilometers. Most of the ice particles escape the moon's gravity, whilst any that don't fall back onto the moon and resurface it, making Enceladus fresh and reflective. As the moon orbits around Saturn, it leaves a trail of ice, forming Saturn's E-ring. Life on Earth is currently believed to have started at the bottom of the oceans from hydrothermal vents. They produce the ingredients and environment necessary for life. So beneath Enceladus's fresh, frozen surface, there may be life. It could be truly alien life, species that we've never seen anything like, or simple life, single-celled organisms. For decades we've seen Mars as our best chance of life elsewhere in the solar system. But the truth is, life may be found first beneath the surface of the moon orbiting a gas giant. This is Saturn's largest moon, Titan. It is a hazy world with a thick blue atmosphere, making it very similar to the Earth, meaning it has a strong potential for life. But it's very hard to see what the surface of Titan looks like. So in 2005, we sent the Huygens probe to land on the moon and reveal its secrets. Hidden beneath the dense haze lies a solid surface. At temperatures of minus 179 degrees Celsius, most of it is frozen, but not all of it. The Cassini probe orbiting around the moon detected lakes on the moon's surface. But the temperature is far too cold for liquid water to exist. So what is it? This is real footage from when the Huygens probe landed on the surface of Titan. In doing so, it became the most distant probe to ever attempt a landing on another world. Once the Huygens probe reached the surface, it saw rocks that had been eroded in the same way rocks here on Earth are by bodies of water. The lakes on Titan are filled with liquid methane. There is potential for life to exist within the lakes of liquid methane on Titan, in the same way that organisms here on Earth live in water. It is possible that as the sun swells in its later stages of life, and it begins to heat the rest of the solar system, temperatures on Titan could reach levels that would allow liquid water to exist on its surface. The period in which this may happen could be several 100 million years, meaning there is plenty of time for life to form. Maybe, if we can manipulate the atmosphere to make it similar enough to here on Earth, it could become a potential second home once our planet is no longer habitable. This is the most distant man-made object ever. The Voyager 1 spacecraft was launched September 1977, just 16 days after its twin, Voyager 2. Their goal was to take advantage of a rare planetary alignment between the gas giants. Voyager 2 would take a slightly different trajectory in order to visit all four of the gas giants, whereas Voyager 1 was only heading for Jupiter and Saturn before the next part of its mission began. They each carried one of mankind's greatest ever collections. This is the Golden Record. On it are a number of images, songs and other sounds from here on Earth. The record also has a set of instructions that will only be understood by intelligent life. Directions on how to play the record, where the record came from, and what the first image on it should look like. The music and sounds are from all across our planet. It features greetings from the people of Earth in 55 different languages.
Hola y saludos a todos.
Tanti auguri e saluti.
有空请到这儿来玩。
Здравствуйте, приветствую вас. Bonjour tout le monde. Konnichiwa.
Hello from the children of planet Earth.
Voyager gave us images of the planets that we could never have achieved here on Earth. It then set off towards Saturn. imaging the planet, its rings, and several of its moons, including the blue atmosphere of the hazy giant, Titan. For Voyager 1, this was the end of its mission to explore the gas giants, but its final mission had just begun. After gaining speed from its orbit around Saturn, it set off into the very edge of the solar system, heading where no probe had ever been before. But before it begins shutting each of its systems down one by one, Voyager was instructed to do one last task: to turn back towards the solar system and take a final image. It produced arguably one of the most powerful photos in the history of mankind. This is the pale blue dot. It may look insignificant, but this faint, fragile point of light is our home. On it is every single human being to ever live. The entirety of our delicate species have all coexisted for only a few cosmic seconds on this pale blue dot. We may be alone in the universe. There may not be any other worlds out there that are capable of supporting life quite like our own, making this speck of dust, suspended in a sunbeam, the most precious thing in our universe. These spacecraft have only pure intentions: to inform others of our desire to explore in our quest for knowledge. Voyager won't find intelligent life. It will need to be found by intelligent life. As it leaves our solar system and sets off into interstellar space, it is alone, adrift in the vast cosmic sea, carrying the hopes and dreams of our entire civilization. By 2025, Voyager will have run out of power. But the record on board will likely last 10 billion years. It will outlive our entire solar system. So if we don't manage to make it off our planet, if our civilization doesn't colonize another world, and we are doomed to die in our solar system and never visit other stars, then at least we have this. At least we have evidence of what we once were. There's a popular theory that the reason we haven't seen other alien civilizations is because civilizations themselves don't exist long enough to interact with one another. And if that's the case and we are doomed to destroy ourselves, then there's still hope. There's still hope that one day an alien civilization will come across Voyager and they'll see all the records of what we once were. And for me, that is why Voyager was the wonder of our solar system. I'm Damon Scotting, and this was Astronomical.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
When you look up at a night sky, it's easy to get lost in the beauty of the stars. But they are just a taste of the endless marvels out there in the cosmos. Invisible to the naked eye, there are things you won't believe. Places where truth really is stranger than the strangest fiction. Out there are immense clusters of stars. Stellar nurseries from when stars are born. Supernova remnants from when stars die. Black holes and other curiosities that have puzzled scientists for centuries and still do today. These are just a few of the wonders of our universe. I'm Damon Scotting, and this is Astronomical.
you see that right there? That is the Orion Nebula. That is the reason I got into astronomy. That is one of the main reasons that I'm here today. Because when I bought my 4-inch telescope after passing my GCSEs, the first thing I found in the sky after the moon was that. And when I saw it through a telescope, it appeared grey. A few tiny stars inside of it, but I could make out structure. I could see it was a cloud of dust and gas. And then when I read about it and heard it was a stellar nursery, and that's where stars are born, that sticks with you, captivates you, it moves you. And that's why I've been hooked on astronomy ever since. Because of that, right there. And you know what, it's been under my nose this entire time. Every time we look at the constellation of Orion, we look straight at the belt, just here. But the real wonder is just below the belt in its sword. The Great Orion Nebula is one of the wonders of our universe.
It is here, deep within the clouds of dust and gas that can stretch for hundreds of light years, that stars are born. Big, small, red, blue, all stars are birthed in the same way. When certain areas of these colossal clouds condense and coalesce, nuclear fusion occurs as the lighter elements are fused into heavier ones. This is the process in which stars generate their energy. These are 3 different images that I captured of one of our nearest stellar nurseries, the Orion Nebula. At the core, visible through the aid of a telescope, is the centre for stellar birth. Stellar nurseries are arguably one of the most beautiful sights in astronomy. Think of all the countless solar systems that are being born right here. Stars rarely form on their own, however. It is far more common for them to form as a group of stars, known as a star cluster. Okay, it should be about that. Yes, okay, alright, so there it is. There we go. So this is the Great Globular Cluster in Hercules. It's a collection of several 100,000 stars that are very densely packed together. In fact, the diameter of this cluster is just 145 light years. To put into perspective for you, if you compare this to the Sun's neighbourhood, then these stars are 100 times more densely packed together. They are so close to one another that they often collide and produce new stars. Star clusters are extremely large groups of stars. They typically come in 2 forms, either a globular cluster, where the stars are packed together in very tight groups of hundreds to millions of very old stars, or open clusters, which are a lot less densely packed together, containing a few hundred, which are very young. This is a Pleiades star cluster, also referred to as the Seven Sisters. It's one of the brightest open clusters in our night sky and easily visible to the naked eye. Here's a picture I took of comet pan-stars passing by the Pleiades. This is a live shot of Caldwell 14, a double cluster. It's another cluster that's easily visible to the naked eye and all the more remarkable when viewed through a pair of binoculars or a small telescope. Open clusters are rarely older than 50 million years, as they are often pulled apart easily due to their loose gravitational bounding, whilst globular clusters are typically 10 billion years old, and were amongst the very first stars to form in the universe. They are all the same age, and as a cluster they orbit on the outskirts of galaxies, meaning they remain tightly bound, uninfluenced by other bodies. Globular clusters are truly a wonderful sight once viewed through the telescope, whilst open clusters are the naked eye gems of the night sky.
Regardless of which you prefer, star clusters are a wonder of the universe. Out there, lurking in the darkness of the universe, there are monsters. These wonders of the universe don't obey the rules of physics. The very laws that govern the universe we exist in break down the closer you get to them. They feast on everything. Nothing is spared, not even stars. This is a black hole.
This is a gravitational well. This shows how space is warped by matter. Now in this example we're going to say this is a black hole. And these are stars. Now black holes are incredibly dense and take up small regions in space, but they have a mass equivalent to millions or even billions of stars. So as you can tell, the black hole is warping space, and this is an object of relatively insignificant mass compared to the black hole. So although a star will have its own distortion of space, similar to this right here, compared on a grand scale, it seems almost invisible. So when we put a star near a black hole, it begins to orbit. As it falls into the center, where the gravitational pull is so strong that nothing, not even light, can escape its pull. This is known as the event horizon, and what goes in never comes back out.
Black holes form when high-mass stars reach the end of their lives and collapse under their own gravity. They really are the most bizarre things in the universe. They are places where truth really is stranger than the strangest fiction. Looking at it, what you're really seeing is the event horizon. The region around a black hole where the gravitational pull is so strong that nothing, not even the fastest thing in the universe, light, can escape its grasp. It truly is the point of no return. But what lies at the centre of a black hole? Many people have different theories about it, but right now we believe there is a single infinitely dense point of mass in space, known as a singularity. We may never know for sure, as there is no way to witness a naked singularity, to cross the event horizon and see beyond, and a return is restricted by the laws of physics. Recently, however, we obtained our first ever true image of a black hole, confirming many of the theories we had. The orange region around the black hole is the accretion disk, formed when stars pass too close and are ripped apart before being swallowed. This is a representation of how a black hole looks from different angles. They distort space-time and bend light. In our galaxy, there are millions and millions of black holes, invisible, with nothing to light them up. One of the ways we can see these black holes is by observing their gravitational influence, noting any stars caught in orbit around them. Black holes will be the last thing left in the universe.
Now the idea of two suns setting below the horizon might seem like something straight out of science fiction, but it's actually more common than you may think. In fact, recent evidence suggests that multiple star systems, where two or more stars orbit one another, are more common than singular star systems like our Sun, which are all alone. So if you were sat upon a planet orbiting a binary star system, then sunsets like this would be a regular occurrence. On Earth, our temperature is mainly determined by our axial tilt. Assuming you're not on the equator, then the amount of sunlight you receive during the year varies dramatically, and so do the temperatures. But another big factor is the distance a planet is from the Sun. Fortunately, the Earth orbits in almost a perfect circle around the Sun, which means it receives the same amount of light and heat throughout the year. But the same can't be said for binary star systems, because planets orbiting around these would have a chaotic orbit. It may be a very stretched circle that varies continuously, or it might even be a figure eight as it goes in between the stars, which means the temperatures will vary extremely on the surface of those planets. And if that wasn't complicated enough, star systems like this can contain 3 stars, 4 stars, 5 stars. Star systems can contain as many as 6 stars that we know of. A sextuplet star system, a true wonder of our universe, and one is visible to the naked eye.
When looking north, one of the first things you notice is the Big Dipper. Shaped like a saucepan, the Greeks named the constellation Ursa Major, meaning Great Bear. In the handle of the Big Dipper, you can see 2 stars very close to one another. 13th century Arabs used these stars to test people's eyesight. Although they appear as just 2 close stars, they are actually 6. This is Mizar and Alsor, a quadruple and binary star system that together form a sextuplet star system. Binary star systems can come in many different arrangements. They can be 2 of the same mass orbiting a common centre of mass. They could be slightly different in mass size, like the Pluton-Charon system. There could be more of a difference in mass, like Earth and the Moon. Or an even bigger difference, an extreme difference, like Earth and the Sun. Maybe they're even the same mass, but they both orbit in an eclipse, with a common centre of mass between them. This is Albireo, which to the naked eye appears as just another star, but with the help of a telescope it is resolved to be multiple stars. Known as one of the best sights in the night sky, it is easily made out for a pair of binoculars, showing a stunning contrast between the red and blue. For centuries we've been limited to appreciating the beauty of the cosmos with just our naked eye. Now we are able to resolve the countless wonders of the universe with tools like telescopes and binoculars that our ancestors could only dream of. These marvels have only become known to us in the past few centuries, but they are just the tip of the iceberg in terms of the true wonders out there that are waiting to be discovered. When high mass stars reach the end of their life, they tend to do something pretty special. This is a supernova, the brightest explosion in the universe. When they happen, they will outshine the entire galaxy before dimming down. The aftermath of a supernova can be either beautiful or terrifying. The size of the star will determine what happens to it after it explodes. Supernovas occur when a star runs out of fuel. Throughout its lifetime, it is in a constant balance between the outward force of radiation and the inward pull of gravity. As the outward force of radiation begins to run out, gravity wins over, and the star collapses inwards on itself, before it either rebounds to produce a supernova remnant, or, if the star is extremely massive, a black hole. The speeds at which the star collapses are fairly close to the speed of light, but the afterglow of the explosion can outshine their host galaxy for weeks. This is the Crab Nebula. It is a supernova remnant, a star that went supernova in the year 1054. It was recorded back then by Chinese astronomers and described as a second sun in the sky. That's how bright it appeared to us here on Earth. So how common are supernovas? Well, typically we expect a supernova to occur in our galaxy once every 100 years. However, we haven't observed one since the year 1604, which means we're long overdue. One star that could potentially be going supernova very soon belongs to the constellation of Orion and is one of the brightest stars in our night sky.
Now, one of the most iconic parts of the constellation of Orion is Betelgeuse. Now, you'll see Betelgeuse on the top right hand side here. It's known as a shoulder star. Betelgeuse is a super red giant. And the reason that's special is because it's on the verge right now of going supernova. In fact, it may go supernova anytime between now and 1 million years or so in the future. Now, because Betelgeuse is relatively very close to us, only 430 light years away, when it does go supernova, it will be visible to us during the daytime. In fact, it'll appear as a second sun. Odds are Betelgeuse could shine as bright as a full moon. But this will only last for a couple of days because supernovas are very short-lived flashes. In fact, some of them can be brighter than the core of a galaxy. And you think the core of a galaxy is a black hole swallowing thousands, maybe even millions of stars, ripping them apart. So for a supernova to be brighter than that, means it's something special. Now, when supermassive stars reach the end of their lifetime, they tend to go out in one of two ways. The really massive ones, with a mass more than 30 times that of our Sun, will form a void in space known as a black hole. But then those that aren't quite as massive, but still have a mass between 10 to 29 times that of our Sun, will form one of the densest objects in the universe. This is a neutron star. Immensely hot, with a mass 1 million times that of our planet, yet only a diameter of 20 kilometers, less than that of most major cities. These are incredibly dense.
The pressure at the core of a neutron star is very intense. The particles that would normally repel each other in any other circumstance are forced together. Protons and electrons fuse to form neutrons. Neutrons have no net charge, meaning they can get as close to each other as they like, leading to these stars being amongst the densest objects in the universe. They have magnetic fields that are trillions of times larger than that on Earth, which is what makes them easier to detect given their small size. In our galaxy, there could be as many as 100 million neutron stars.
Now, in order to show you just how dense neutron stars really are, if you were to take a sugar cube of neutron star matter, then it would weigh the same as Earth's tallest mountain, Mount Everest. This little sugar cube would weigh the same amount as every single human being on planet Earth. All 7.8 billion people would weigh the same amount as this sugar cube of neutron star matter.
But as if they were not enough of a wonder, something truly astonishing happens when two of these stars get too close to one another. They collide and produce what is known as a killer nova. Recently, there have been suggestions that most of the heaviest elements in the universe were not formed from supernova explosions, but instead from killer novas. The likes of gold and uranium form when neutrons become freed and almost immediately coalesce to form these rare elements. There is still plenty to learn about neutron stars, but even now, they are a wonder of the universe. Over the past century, we have solved a lot of the big mysteries in science. Ernest Rutherford discovered the atomic nucleus, Edwin Hubble discovered that our Milky Way is just one of many galaxies, and Watson and Crick revealed the true structure of DNA. But perhaps the biggest unsolved mystery facing science today is what the universe is really made of. Everything you see around you is made up of matter. Matter is anything that has a mass and takes up space. But when we look out into the universe, things don't quite add up. There simply isn't enough matter for things to be the way they are. Galaxies shouldn't really exist as normal matter isn't strong enough to bind them together and form their complex structures. Something else is out there. Something that doesn't produce or reflect light. So we have decided to call it dark matter. It makes up 85% of our universe, as opposed to the 15% that is normal matter. If it weren't for dark matter, then galaxies would not rotate as fast as they do and stay grouped together. Instead, there would be a random arrangement of stars across the universe, as opposed to being a part of supermassive clusters that are galaxies. It does interact with gravity, and as far as we can tell, there must be a lot of it. It seems fair to assume that dark matter is made from an exotic particle that simply doesn't interact with light in any way that we have encountered before. We know very little about it, but it is crucial to understanding the universe and everything in it. In the same way that discoveries about the atomic nucleus and the existence of other galaxies have shaped our understanding of science, it seems only right to assume that when we do one day solve the problem of what dark matter really is, it will become a true wonder of the universe. But for now, it is a mystery.
Space is mostly desolate. It is incredibly vast, but the majority of it is completely empty. However, in the dark stretches of our cosmos, there are infrequent glimmers of hope. There are islands. Islands containing billions of stars, billions of other solar systems. These are galaxies. Massive collections of stars, stellar remnants, interstellar gas, dust, and dark matter, all bound together by gravity. And at the core of almost every single galaxy is a supermassive black hole. Around the central regions are the red dwarfs. These are amongst the oldest stars in the universe. Whilst the outer reaches of our galaxy is filled with young blue stars. The Milky Way is an average-sized galaxy. It has a diameter of 100,000 light years. Galaxies come in many different shapes and sizes. Here are just a few that I've imaged through my telescope. Now the universe is expanding at an accelerating rate. The galaxies are moving further and further away from each other. And one day, we may be unable to visit another galaxy because the space between us is so vast. But one day, we will visit another galaxy without having to ever leave our solar system. In about 4 billion years' time, our nearest spiral galaxy, the Andromeda Galaxy, will merge with the Milky Way. The Andromeda Galaxy contains 1 trillion stars. It's 2.5 times larger than the Milky Way. It will light up the night sky like never before.
The result of these two galaxies colliding will be a new galaxy that is very different to either of them right now. It will be called Milkdromeda and will resemble a giant elliptical galaxy. During this process, it is possible that our own sun may be flung out of the Milky Way into interstellar space.
Now when these two galaxies merge, it is very unlikely that any of the stars will collide with one another. And that is because the space in between the stars is incredibly vast. One thing is for certain though, that if anyone is left behind to see this spectacle, then they will be able to truly appreciate what is one of the wonders of our universe. I'm Damon Scotting, and this was Astronomical. 50 years ago today, the history of mankind was changed forever.
It's one small step for man, one giant leap for mankind.
As we set foot on another world for the first time. Just over 100 years ago, we developed the first airplane and left the surface of planet Earth. Now we're closer than ever to leaving footprints on another planet. It is in our genetic code to seek and discover new adventures. We are explorers. I'm Damon Scotting, and this is Astronomical. Now, for the most part of human history, we believed that we were at the center of our universe. and that the moon, planets, sun and stars all orbited around us. But it wasn't until the 16th century when a Polish mathematician named Nicholas Copernicus disproved this idea. He proposed a new model, a heliocentric one in which we were no longer at the centre, but instead the sun was. This solved many problems, including why planets move in a retrograde motion through our night skies. But it wasn't very quickly accepted. It required a lot of evidence to be built up to support it. One of the strongest points was when Galileo discovered Jupiter's 4 largest moons. Proof that not all bodies orbit around the Earth. Think of the countless generations that grew up and spent their entire lives believing that we were at the centre of our universe. It was truly a reality-shattering realisation. Now, although we weren't at the centre of our solar system, what about the rest of the universe? Were we still at the centre of it, or was that not true either?
Up until 100 years ago, we lived in the beautiful ignorance that our galaxy was the full extent of the universe. The millions of stars you were capable of seeing through a telescope were all there is. Then, Edwin Hubble discovered another island of stars that seemed to be very far away. Hubble estimated that they were not within our galaxy, but were in fact 900,000 light years away from us. This was the Andromeda Galaxy. We know today that it is actually a lot closer to 2.5 million light years away, but what Hubble did was expand our horizons further than anyone ever before. Before Copernicus in the 16th century, we imagined ourselves to be at the centre of a universe that ended with the 6,000 or so stars we can see in the night sky. It wasn't until 1924 that Hubble lifted the curtain of our night skies and revealed other galaxies, immense collections of billions and trillions of stars. Based on today's knowledge, we think the universe is 93 billion light years in diameter and contains somewhere in the region of 200 billion trillion stars. But like our ancestors before us, we may be looking at the universe through a microscope. Its true extent may go well beyond our observable universe. Perhaps there may be even multiple universes. The more we explore, the more we discover. Human technological advancements are proceeding at an ever-accelerating rate. At the start of the 20th century, the Wright brothers developed the first airplane and took to our skies for the very first time. A monumental achievement that was to appear practically insignificant just 50 years later. After the Second World War, America and the Soviet Union were going head-to-head in the Cold War. An event that indirectly sparked one of mankind's greatest ever achievements. This was a space race. Each nation was eager to flex their ballistic missile capabilities, which as a result led to the rapid development of spaceflight technology. It seemed as though wars were no longer going to be fought in the trenches, but now instead, the skies high above. Surely whoever controlled the space above our planet would be the most dominant force on Earth. The Russians achieved the first spaceflight milestone by launching Sputnik 1, the first ever satellite, into orbit around the Earth. This caused panic in America. The newspapers were quick to run with the fear that a Russian satellite orbiting above was terrible news for the freedom of their nation. The Americans responded with their own satellite just 4 months later. And they were second place again in 1961, when the Soviet Union launched the first man into space. Cosmonaut Yuri Gagarin. The Americans soon followed, with astronaut Alan Shepard becoming the first American to orbit the Earth. But the humiliation facing the Americans was becoming unbearable. The Soviet Union was winning on all fronts. This failure prompted one of the most powerful and profound speeches ever given in the history of mankind. It would lead us to one of our greatest ever achievements and change the course of history forever.
For we meet in an hour of change and challenge, in a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. We set sail on this new sea, because there is new knowledge to be gained and new rights to be won, and they must be won and used for the progress of all people. Can we help decide whether this new ocean will be a sea of peace or a new terrifying theater of war?
Up until this point, President John F. Kennedy had never been a big supporter of America's space ambitions. He'd recently declined a proposal that would land a man on the moon before 1970, deeming it too expensive. But now, due to recent space failures and the embarrassment that was the Bay of Pigs invasion, America needed a win, and it needed a big one. They needed one that would achieve more glory and was more ambitious than anything ever attempted before. The goal now wasn't just to get a man into outer space. It was to land one on the moon.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
The speech resonated not just across America, but the entire world. The goal to land a man on the moon had never been attempted before, and the budget necessary to do so did raise a few eyebrows. But JFK delivered a speech in such a way that ignited the imagination of the entire nation. It is still today one of the most moving and inspiring speeches ever given.
However, I think we're going to do it. And I think that we must pay what needs to be paid. I don't think we ought to waste any money, but I think we ought to do the job. And this will be done in the decade of the 60s. It may be done while some of you are still here at school at this college and university. It will be done during the terms of office of some of the people who sit here on this platform. But it will be done, and it will be done before the end of this decade. And I am delighted that this university is playing a part in putting a man on the moon as part of a great national effort of the United States of America.
Tragically, JFK was assassinated a year later, meaning he would never get to see America finish the path he set them on. The goal to land a man on the moon is still today the most ambitious goal ever set by a nation. It would need plenty of support behind it. America continued on with the mission, regarding it as JFK's legacy. He's still today one of America's most beloved presidents, and this speech is one of the main reasons why.
The pressure was now on, to complete one of mankind's most ambitious targets, and to do so before the decade was up. NASA announced a number of programs and missions that would slowly prepare us to land on the moon. However, after a disastrous start to the Apollo program with Apollo 1 that led to the gruesome deaths of all 3 astronauts, the mission was under more scrutiny now than ever. It was going forward at a relentless pace that NASA seemed unable to keep up with. Nevertheless, they kept going, with the next few Apollo missions containing no crew. By Apollo 8, they had a manned crew successfully complete an orbit around the moon before landing back on Earth, achieving one of the most magnificent photos ever taken. This is the Earth Rise.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty? Hey, don't take that, it's not scheduled. You got a color film, Jim? Hand me a roll of color, quick.
Oh man, that's great. Where is it?
Quick.
11.
Apollo 9 and 10 were the last dress rehearsals that prepared us for the most important mission to date, Apollo 11. The first mission that would attempt to successfully land a man on the moon and then return them back to Earth.
Liftoff. We have a liftoff.
Neil Armstrong, Buzz Aldrin, and Command Module pilot Michael Collins were all preparing to make history. Then, on July 16th, 1969, the Saturn V was launched. The most powerful rocket ever built. America held its breath as they began their journey.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said because it is there. Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked. Thank you.
30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. Down a half. 30 seconds. Forward. Just contact light. Okay, engine stop. APA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Thank you.
Neil Armstrong then wrote himself into history, gaining immortality as he took his first steps on another world. He then uttered some of the most famous words to ever be spoken.
It's one small step for man, one giant leap for mankind. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation.
Buzz Aldrin joined him on the surface 20 minutes later. The two gathered samples of moon rock and conducted a few experiments before then heading back to the command module and returning to Earth as heroes. JFK's goal had been reached. America's dream had been achieved. Although they were outperformed by the Soviets throughout most of the space race, they had beaten them towards arguably the most ambitious goal, leaving footprints on the moon.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
America didn't stop with Apollo 11. They carried out 6 more subsequent missions, 5 of which were successful. Each new mission was more daring and aspiring than the last. The goal now was to gain more scientific data surrounding the moon and the solar system's formation. This is a 3D model of the Apollo 15 landing site. One of the main issues that faced the astronauts on these missions was they couldn't venture very far from the lunar module, because the spacesuits they were wearing were very heavy. So, in order to get around this problem, on Apollo 15 they introduced the Lunar Rover. As America had reached its goal, the Apollo missions became less and less appealing to the general public, and the funding was cut, meaning the Apollo 17 mission was to be the last.
Gene Cernan is, as of today, the last man to walk on the moon.
99, proceeded, 3, 2, 1, ignition. Right away, Houston. America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Godspeed to crew of Apollo 17.
The Apollo missions captured the public's imagination like never before. But this is just the beginning of our exploration of space.
Do you see that bright star-like object just over there? That's not a star, and it's not a plane either. That is the International Space Station. It's moving at 17,500 miles per hour, and aboard it right now are 9 astronauts. They're moving around the Earth so quickly that in 24 hours they'll see 16 sunrises and 16 sunsets. Every single day.
The ISS is a modular space station in low Earth orbit. It is the result of communal efforts from America, Canada, Japan, Russia, and Europe's space programs. Roughly the size of a 6-bedroom house, it is the perfect environment for astronauts to conduct tests on human habitation and how well we adjust to the effects of microgravity, ultimately determining whether or not future missions to other worlds are viable. The International Space Station has never managed to capture the public's imagination quite like the Apollo program did. Nevertheless, the public are becoming increasingly involved with the activities being carried out during these scientific missions. Astronauts often work long, hard days aboard the ISS, but they still generally manage to find time to teach the rest of us about life in space, and how even the most mundane, simple day-to-day tasks that we do here on Earth can prove quite challenging. The long-lasting effects from living in outer space can lead to some very serious health problems. At the moment, astronauts rarely spend more than 6 months in outer space at a time. It is very important to monitor an astronaut's health after they return back from space, in order to ensure there are no long-lasting effects. Setting up a habitat on another world is a long-term goal. We are not quite there yet, but we are moving closer and closer to having the first ever humans live for long periods on another world besides the Earth. At its closest approach, Mars is still 8 months away from us in terms of travelling through space. This presents a number of potential challenges for the crew to deal with alongside the main goal, which would be to explore Mars in greater detail. Although the idea of producing a viable habitat on Mars seems a little out of reach at the moment due to Mars's hostile environment, there are ways in which we could manipulate Mars's atmosphere in order to replicate that on Earth. If we could do so, then Mars may become a suitable second home that is becoming increasingly more necessary given the way we are treating this planet. But the possibilities for new worlds to live on doesn't end there. Although none of the other planets present much chance of settling down and establishing a colony, there are a large number of moons that hold the ingredients that may harbour life. Enceladus and Europa each orbit one of the 2 largest planets in our solar system, Saturn and Jupiter. These 2 worlds do have similarities, in that they both have a very large potential for extraterrestrial life being found beneath their icy crust.
Now when Europa orbits Jupiter, it does not do so in a perfect circle. Its orbit is slightly squashed, which means there are points when it goes around Jupiter where it's closer and further away. This causes the core of the moon to warm up through a process known as tidal heating. So beneath its frozen icy surface, the oceans of water are being warmed constantly. This makes it an active moon and perhaps the ideal environment in which life could arise. The same applies for Enceladus. Perhaps one day we could live beneath these frozen icy surfaces.
Titan is Saturn's largest moon. Much like Earth, it has a thin blue line encircling its atmosphere. This dense, hazy world has remained a mystery to us for a long while. We wondered what lied within the dense atmosphere. So, we sent the Huygens probe to land on the surface and investigate.
Now, when we landed on Saturn's largest moon, Titan, one of the first things we noticed were the rocks on its surface. These resembled those we'd find on Earth, more specifically those around a riverbed. This brought us to the same conclusion, that these rocks had been eroded by a body of water. And indeed, the Cassini probe orbiting around Titan discovered very large lakes of liquid methane. Now on Earth, methane is a gas, but when the temperatures are lower, it can become a liquid. And indeed that is the case on Titan.
As the sun reaches the end of its lifetime, it will swell into a red giant, warming the outer reaches of the solar system. The Earth's oceans will be boiled away, but there is a high likelihood that the cold distant moons of our solar system could be warmed to a suitable temperature, allowing us to colonise all of them. One day, we may need to leave our solar system in search of another star that gives us the energy and support we need to continue and further advance as a species. This would require travelling through interstellar space, the space in between stars. If the trips to Mars and other moons seemed long and risky, they are a taste of paradise compared to the extreme conditions of interstellar travel. The distances between stars is incredibly vast. It will not be an easy journey for us to make if we are to ever travel to another solar system. But our desire and relentless curiosity means it is practically inevitable that we will one day venture to other stars.
Our knowledge of the universe's true size has grown tremendously in recent times. But there is still nothing to say we fully understand its true extent. With every second, the universe is expanding more and more. But this just simply means there is more space for us to explore. As a species, we are no longer limited to our own skies. The universe calls to us. It awaits our arrival. Exploring our own solar system will be the first steps towards colonizing the galaxy. We are explorers. I'm Damon Scotting, and this was Astronomical. One day, the sun will die. As it does, it's going to swell into a red giant, over 100 times its size at the moment, and engulf the Earth. It's going to boil our oceans, burn the planet to a crisp, and eliminate all life on our surface. In fact, one day, the last star in the universe will die. And as it goes out, the universe itself will be cast into eternal darkness. There will be nothing left. So the question is, when will the universe die? I'm Damon Scotting, and this is Astronomical. Now in the first episode, we look back to the birth of our universe and how after 13.8 billion years we got to where we are today. Now, in the series finale, we're going to look forward in time and figure out just how and when the universe will end. So let's start with a small leap forward in time. How different will our universe look in just 10,000 years? Come with me as we venture into the future.
In 10,000 years, the red supergiant Antares will go supernova. It is a star 12 times the mass of our own Sun, with a diameter roughly 500 times larger. If it were to swap places with our Sun, then it would extend beyond the current orbit of Mars. The resultant supernova will likely shine as bright as a full moon and be visible to the naked eye during the daytime. There will be a simultaneous total solar eclipse and transit of Venus. Vega will become the new North Star as constellations start to become unrecognisable. This will be the end of the projected lifespan of the Svalbard Global Seed Vault. The vault preserves an enormous variety of plants and seeds from the event of a global crisis. The Sahara will become tropical. Voyager 1 will move to within 3.4 light years of our nearest stellar neighbour, Proxima Centauri. The Chernobyl exclusion zone will return to normal levels of radiation. The northern polar ice cap on Mars will begin to recede as the red planet reaches a warming peak in its northern hemisphere.
"10,000 years was the most probable lifespan of a civilization according to the Frank Drake equation. But if we make it beyond that, to say 1,000,000 years, then we will be around to witness some truly special events."
After 1,000,000 years, Neil Armstrong's and the rest of the Apollo moonwalkers' footprints will have disappeared from the surface. The Great Pyramids of Giza will have eroded beyond recognition. The stars in our night sky will have moved independently at different speeds throughout our Milky Way. This will lead to constellations no longer resembling the way they appear to us now. By this point, the red supergiant star Betelgeuse will have exploded into a supernova. For at least a few months, the supernova will be visible to the naked eye on Earth. There will now be a void in the shoulder of Orion. We will have surpassed the time required to terraform Mars. This is an optimistic and pessimistic moment in time, depending on the way you look at it. It is the shortest estimated time by which humanity could potentially colonise our Milky Way galaxy and become capable of harnessing all the energy of the galaxy. This is largely based on the assumption that we will be capable of reaching a velocity that is at least 10% the speed of light. But there is also a 95% probability that humanity will be extinct by this date, according to the Doomsday argument. There will likely have been at least one eruption of a super volcano. Mars's two moons, Phobos and Deimos, will collide and form a ring encircling the red planet. Whilst much further into the future, 100 million years or so, the rings of Saturn will have disappeared. The Sun's luminosity will have increased by 1%. This is the beginning of the end for our solar system.
As the Sun grows in size and luminosity, the region around it, known as the habitable zone, where it's not too hot and not too cold, will expand with it, meaning the Earth will likely boil away. So in order for us to stay alive, to stay on a habitable world, we will need to move the Earth further away from the Sun. This will require a grand astro-engineering project. We'll need to use asteroids to give us gravity assists to move further away from the Sun. In 5 billion years, one of the greatest night sky spectacles will take place as the Andromeda Galaxy and Milky Way merge.
Over the course of the next few billion years, these two galaxies will engage in a beautiful celestial ballet.
Very few stars will actually collide with one another whilst this is happening. This is due to the vast distances in between the stars. But there will be a considerable number of stars that are ejected from this new galaxy that is to be known as Milk Dromeda. Now that the hydrogen supply at its core is exhausted, the Sun will start to leave the main sequence phase and evolve into a red giant. The Sun will engulf the Earth and Moon. By this point, however, any life that was left on the Earth will be long dead, due to the new searing temperatures on its surface. The Sun will swell to as large as 256 times its radius today. Although this is terrible news for our planet, assuming we cannot do anything to alter its distance from the Sun, this will be a new era of life elsewhere in the solar system, as moons such as Titan will likely reach surface temperatures that are now suitable for life.
Now this is a very peculiar point in the life of the universe, because it can take one of three different routes, and this depends largely on the rate at which it continues to expand. The universe could end as early as 22 billion years from now, in what is known as the Big Rip.
The Big Rip model of the universe is based off the idea that the expansion of our universe will start to increase to infinity in a finite time, meaning all matter in our universe, including every galaxy, star, subatomic particle, even space-time itself, will be ripped apart, leaving nothing behind. This idea depends on the amount of dark energy in our universe. This affects the rate at which the universe expands. So if dark energy can increase without limit, then we will reach a point where it will overcome all of the forces that hold our universe together. This is just one potential end to our universe.
Now if the universe does continue to expand, then our nearest galactic groups will move so far apart from one another that we will no longer be able to see them. The redshift from these galaxies will be beyond our point of view, meaning any civilizations that are born after this point in time will look out into the universe and see only our local galactic group and think that is all there is and all there ever was.
Galaxies are very far away from one another. It is unlikely that we will ever be able to venture to a galaxy outside our own local group, as the universe's continuous expansion is stretching us further and further apart, meaning we will need to be able to one day find a way to travel across these immense cosmic distances in a small region of time. If we don't, then they will have all moved well beyond our view. The universe contains somewhere in the order of 200 billion galaxies that we know of. Any newborn civilizations at this point will look out into the night sky and see only the few within our local group, and accept that this is all there is out there and all there ever has been, because there is no proof otherwise. Their entire universe will consist of the few trillion stars within our local group.
However, if the universe does begin to stop expanding and instead starts contracting on itself, then this will be a far more optimistic end to our universe's life, as all the galaxies that were once too far from one another to see each other will now begin to contract and slowly coalesce until a point of single infinitely dense mass, and then perhaps a big bang. The universe will continue to repeat itself in what is known as the Big Crunch.
The Big Crunch scenario assumes that the density of the matter in our universe is high enough that everything will soon begin to contract under the influence of gravity, overcoming the expansion of our universe. This theory is also referred to as the Big Bounce. The galaxies will all slowly start to merge together, and the temperature of the universe will increase so much that it will now be hotter than the surface of most stars, before eventually collapsing into a singularity and then maybe, just maybe, producing another Big Bang. This could be the way in which our universe was formed. Perhaps this is the cycle of the universe. There is never an end, just a new beginning.
But out of all of these potential outcomes, perhaps the most likely of them all is the Big Freeze. Otherwise known as the heat death of the universe, it's based on the idea that it will continue to expand forever. And at this point in time, 10,000 times the current age of the universe, no more stars will be born. It will be the end of the Soliferous era. There will be no more starlight in the universe, and it will be the beginning of the degenerate era.
All of the stars in the universe have now exhausted their fuel. In what was once a rich galaxy filled with trillions of stars, there are now only 100 remaining in our Milky Way. The longest living stars, such as the low-mass red dwarfs, have a lifespan that is approximately 10 to 20 trillion years. But soon they, alongside the white dwarfs, brown dwarfs and neutron stars, will all die out. The only new stars that will be born during this period are through incredibly rare star collisions. They will lead to supernovas and a new star will be born, but will not last very long. One day, the last star will go out, and the universe will be cast into eternal darkness. This is the beginning of the black hole era.
Now at this long distant point in the future, the only source of fuel for an exotic civilization will be that from a rotating black hole. But even black holes die. After the last one has disappeared through Hawking radiation, there will be no more black holes left. At this point in time, it is 10,000 trillion, 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 trillion years into the future.
Any hope of harnessing energy in this now bleak universe will likely come from using the rotational energy of a black hole. Black holes were once believed to be eternal, until Stephen Hawking discovered that along the event horizon of a black hole, the region known as the point of no return, there were interactions between particles and antiparticles. When the two separated on the very edge of the event horizon, one would be swallowed and trapped, whilst the other broke free. Through this process, black holes slowly release energy, and after incredibly, immensely, ridiculously long periods of time, they start to dissipate, and the universe becomes even emptier. As the last black hole dies, there is nothing remaining. This is now the dark era.
Now the last possible outcome for the universe is the Big Freeze, otherwise known as the heat death. And this is based on the idea that the universe will continue to expand forever. And after the last particles are removed from existence, there will be nothing. No movement, no activity, no life. Time will have become meaningless. This will be the end of time. Now the end of the universe might seem pretty bleak. It might make you question, is there any meaning to life at all? Well, the answer is yes. Right now we're at the beginning of our journey. We as a civilization have existed for the cosmic blink of an eye. The best is still yet to come. One day we will venture to another solar system. One day we may encounter alien life. One day, we will die. But our inevitable demise won't occur before we venture out to new worlds and new stars. 100 years ago, we didn't know there were other galaxies out there. 400 years ago, we believed we were at the center of our solar system. Imagine how small our universe would have seemed back then and how big it is now. Right now, we're living for the golden age of exploration. And you might take joy in the wonders the universe has waiting for us. We are just a few cosmic steps away from discovering them. I'm Damon Scotting, and this was Astronomical. 3, 2, 1. Mountains. Oh, hello. Welcome back to Astronomical. To catch you up to speed, about the planets, we split them up into 2 categories. You have the inner rocky giants. Nah, fuck it. Fuck that one. Okay. 3, 2, 1.
Alongside the likes of the Colosseum, Great Pyramids of Giza, and Chichen Itza. This is Machu Picchu. I'm so hungry.
What do you say? Machu Picchu, yeah.
And wonders lie ahead. And 1. One day, the sun will die. Oh, maybe. Nope. Okay. 3, 2, 1. Oh, it's a massive crowd down there. Yo! The smallest of the gas giants. It's okay. It's okay. Here. Use it as a marker. Cool. We'll do another take. He's just trying to do his job. He's a good guy. No! Remember when you're growing up and you're watching those cartoons and you see them deal with quicksand and you think, you know what, I'm ready. When it comes to dealing with quicksand in real life, I'll be ready. And then you get older and you think, why did they teach us that? We're never going to need to learn that. Well, now I could have really used that information. And still do today. These are just a few of the wonders of our universe. Okay, let's go again. When we look up at the night sky, we can see roughly 6,000 stars with the naked fuck. See how big that bat was? Yo! That was fucking huge. Well, that's enough filming for forever. There could be a lot more. Should have prepared the speech, and I'm gonna do that when I get back, work on the speeches more. Okay, coming in for a far. All right, 3, 2, 1. One day, oh wow, the cameras, no! Larger than our own, went supernova. It scattered its enriched goods across the universe. Goods made of, Need to sneeze now. I can't start talking until I need to. Have you got that in slow-mo? No, now my nose is bleeding. Who the f bleeds? It's so warm. Okay. Do I leave the boot behind? I'm so tired. Now, on Mars, I am These were Ganymede, Callisto, there's people behind me, giggling Asian girls. Sorry. Cheers. You know what? I think the blooper video is just going to be this. Now this is an actual piece of moon rock. It might not look very special, but this is as old as the solar system itself.
Okay, so you may remember this spot from last week where I was filming and I got stuck in the mud. Well, today I was walking down the same field trying to get to the area where I want to film my final scene for Astronomical, like the season finale, and I got chased down by some cows. So now I tried to run down to this bank for shelter, and that did not work.
I've ripped my jeans. I have completely ripped my jeans. Oh no. You fucking melon. Oh, head. Yeah, I have truly and completely. As well as being the biggest planet in the solar system, has the most amount of moons. Okay, hang on, let me wait for traffic to stop. Okay. Oh, fuck that bike. Let's try it again. Loud noises. Tell you what, this water doesn't feel like salty or anything, that's cool. That has just went all down my jeans. Oh my god, my face stings. There is salt in that water. Times bigger than Everest. A storm big enough to engulf our world multiple times, and a moon with more volcanoes than the whole of Earth. These are just a few of the Ninus. That's what I get for filming in London. I'm just going to say this as what it is, a fucking disaster. I don't remember what I was talking about. Space. There's a collection of several 100,000 stars that are densely packed together. So dense, in fact, that the diameter. Fuck. Okay, let's go again. And there will be nothing left but the vacuum of space. That if anyone is left to see this wonder occur, it will truly be a sight to behold. Okay, damn it, 3, 2, 1.